So let's check these out. So in this example here, if I'm trying to factor this, I cannot use any quadratic skills yet because this is a cubic, but I do see a common factor, and I do see that all the terms have an x. So I'm definitely going to pull an x out. And it looks like the numbers have a common factor as well. So I think I'll pull out a 2x. I think that's the greatest common factor. So let's pull out a 2x. And what I'm going to be left with, 2x times what is going to give me this whole mess. So 2x times what is 2x cubed? That would just be x squared, right? 2x times x squared is 2x cubed. The exponents add. And then plus 2x times what is 4x squared? That should be 2x, right? 2 times 2 is 4. X times x is x squared. And then minus 3, right? 2x times negative 3 is negative 6x. So this whole thing equals 0. All right, so I'm getting there. And I actually have a quadratic here. And this is nice because with quadratics, we can factor things a little simpler. All we need to do with quadratics, kind of the first thing you would do is look for two numbers that multiply to AC, which for us, A is 1, C is negative 3. So A times C is negative 3. So they need to multiply to this number, and they need to add to B, which is 2. So take a sec, think of those numbers. What two numbers multiply to negative 3 and add to positive 2? Let's see. So it looks like our numbers would be 3 and negative 1, if I'm seeing this right. So it looks like we can probably factor this as x plus 3, x minus 1. So again, if I multiply this all together, I will get this up here. So I didn't change it, I just rewrote it. And I still have the 2x. So I just rewrote this bit as this bit, x plus 3, x minus 1. So now when you see it in this form, it's going to make it easier to understand why we're doing this in the first place. Because now the question is, so let's think of the question here. They're asking us to solve. They're asking us to figure out what x's could I plug in to make the whole thing 0. The problem is that would be a guessing game here, right? I have no idea what numbers are going to work. But look at this. I've rewritten my equation like this, and now it's a little easier to find numbers that I can plug in to make this equal to 0. Why is that easier? Because, well, let's say 2x equals 0. Well, if 2x equals 0, that means that x would have to equal 0. So when x equals 0, I know 100% guaranteed that this whole thing is going to equal 0. How do I know that? Because it's all being multiplied by 0. It's all being multiplied by 0. So even if this is a million or 10 million or negative a billion, if I multiply that by 0, the whole thing is 0. So I know one answer, one solution, one number I could plug in here to make the whole thing 0 is 0. So one answer is 0. That is going to be one of the x-intercepts of your graph. How many answers are we looking for? We're looking for 3 because this is a third degree polynomial. So I need 2 more. And the 2 more, right? Same concept. When x plus 3 equals 0, this whole thing will equal 0. It doesn't matter what anything else is because you're just going to multiply it by 0. So if I set x plus 3 equal to 0, one of my answers is going to be negative 3. Negative 3. So I have negative 3 as a solution. I'll put it there on the graph. And last one is going to be positive 1, because if you plug in positive 1 here, the whole thing is going to equal 0 because this little chunk will equal 0. So our answers should be 0, negative 3, and positive 1. And if we wanted to sketch this, some things we might do, the end behavior. So this is cubic, and it's a positive leading coefficient. So I know it's ending up on the right, and it's ending down on the left. And other than that, so if it's negative on the left here, it's got to be positive here. I see no multiplicities. It's going to look vaguely like this, just this general shape, right? Going up to the right, down to the left. It's going to be positive in between negative 3 and 0, and negative in between 0 and 1. So that's kind of the general shape we'd probably be looking at. All right, next question. All right. So looking at this one, this question actually gives us an answer right off the bat. So take a second, think, can I find a solution already by just looking at this? So take a second, pause, think of that. So one of the solutions we can already find is 3. So if you plug in 3, right? So if we plug in 3 here, right, this is going to be 0. So this could be whatever it wants to be. This could be 1 million or 10 million. It's not going to be, but it could be. And it doesn't matter because we're going to multiply it by 0. So one of our solutions is 3. If I plug in 3 for x, the whole thing is going to equal 0. Now the question is, what other numbers could I do that with? What other numbers could I plug in? So in order to find those other numbers, there are 2 other numbers, and they're going to be found here. How do I know there's 2? It's quadratic here. 2 solutions. 1 solution, 2 solutions. So what I'm going to do is, I see a leading term that is not 2. So you have 2 choices here. You can use the quadratic formula. If you use the quadratic formula, you will find your answers, but you're technically not factoring. So let's go ahead and factor. So if I want to factor this expression, 2x squared plus 7x plus 5. So similar to when we were factoring quadratics before, I need 2 numbers that multiply to AC. In this case, that is 10, because A is 2 and C is 5. And then they need to add to 7. So what 2 numbers multiply to 10 and add to 7? That should be 5 and 2. So now be careful, because you might want to say, okay, let's factor as x plus 5, x plus 2. The problem with that, think about what factoring is. These 2 things need to be able to multiply back to what we had before. And they don't. They don't. Look at this even. The 5 and the 2 give you 10, not 5. So something's wrong here. When A is not 1, in our class, the method we've used is the box method. So let's go ahead and take our numbers 5 and 2 and use the box method. So in the box method, what we do is we draw a nice little box here. And in the top left always goes the leading term of our quadratic, so that's 2x squared. And you only need to do this when the leading term is not 1. The leading coefficient is not 1. So 2x squared, and in the bottom right will go your constant term. For us, that's 5. What 2 numbers go here and here? Those are the 2 numbers you came up with that multiply to AC and add to B. And they're going to go with an x. They're going to go with an x. So 5x and 2x. So then pulling out common factors. So we're going to go across each row, pull out the common factor. So between 2x squared and 5x, I can only pull out x. 2x and 5, I can only pull out 1 plus 1. And then going down, 2x squared and 2x, I can pull out 2x. 5x and 5, I can pull out 5. So I can now factor 2x squared plus 7x plus 5 as 2x plus 5 times x plus 1. You can always check that. 5 times 1 is 5. 2x times x, that gives us the 2x squared. And then how do we get the 7x? That is 5 times x gives you the 5x. And then the 2x times 1 gives you the plus 2x. So I just kind of checked this, and it does all multiply out. So this is the correct way to factor. So let's undo some stuff. So I've factored it as 2x plus 5, x plus 1. So how does this give me my other 2 answers? I'm just going to take these factors and set them equal to 0. So if x plus 1 equals 0, then x must equal negative 1. So one of my answers is negative 1. And then finally, if 2x plus 5 equals 0, I get 2x equals negative 5, and x equals negative 5 over 2. So that's negative 2.5. I'll say negative 2.5. It's negative 5 over 2, negative 2.5. So it should be somewhere here. If we wanted to sketch this, let's see. Well, it's a cubic. This x times the 2x squared is going to give you a leading term of 2x cubed. So this is a positive cubic. So it's going to end up on the right, down on the left. When I multiply the -3 and the +5, I'm going to get a y-intercept of -15. Now, that would be a little tough to graph here, so I'm probably not going to do that. But just to get the basic idea, I would go down to -15, meet up here, and then back down here. So this would meet the y-axis at -15, the point 0, -15. So this is kind of what a rough sketch would look like. Here's how we factored it. Here's how we found the zeros. Let's check the answer. Thank goodness. That is nice.